So for the sake of this project, I have chosen car sample data, which is a stratified sampling of cars on US roads and current date. I found this dataset on Kaggle and it has around 260 entries with 22 attributes to it. I have imputed missing values referring to Wikipedia. A new user can begin by clicking on instructions. I have personally used version 3 of D3.js and Apache server for hosting the website locally. Attributes are of two types, categorical and numerical. The categorical ones are represented by bar graphs and the numerical ones are represented by histograms. The tab bar on the top, which is left to right scrollable, acts as a menu for all the attributes. Clicking on any one of them will reveal the graph corresponding to that attribute. On hovering on the bars, we can see the value of the bar on top of it. Hovering also highlights the chosen bar for the user. Bars of histograms and bar graphs are gradient colored, that is, the bars with lower values are a lighter shade of yellow, and the bars of higher value are darker. For example, if we see in this attribute called highway mileage, if you see the bin number 30 to 35, it is darkest because it has the highest frequency count, which is of 84. The bins can be adjusted by clicking on the graph and moving the mouse towards left or towards right. If we move the mouse from left to right, it will increase the number of bins, and if we move the mouse from right to left, it will decrease the number of bins, like this. This benefits the user because now he can drill down and up and basically control the granularity of the data which he sees. A pie chart can provide the user with a different view of the same data with respect to categorical data. In simple bar graphs, the user can visually see the frequency of a given category. On double-clicking on any of the bar chart, we are taken to a pie chart representation of the same data. This gives us further insights into how much percentage contribution does a given category hold in the entire dataset. Hovering over the arcs of the pie chart will expand them and denote their percent share on the centroid. We can also see that the feature under consideration is denoted at the lower left corner of the screen. For example, as we can see that Toyota holds the highest market share of cars on American road. Note that pie charts are not best suited for numerical data, and double-clicking on any bar of a numerical data will just throw an error message to the user. So let's walk quickly through all the attributes of our dataset. So first would be the aspiration. Basically, it tells if the engine type is standard or has a turbo engine in it. As we can see that generally they are standard engines because they're used by the mass. Body style tells you the type of car it is. For example, if it is a sedan, if it's a hatchback, a convertible, looks like the American people have chosen sedan as their favorite here, counting to around 46% of the cars on road. The city mileage is is tough contender, around 15 to 20, 25 to 30. These are the ranges. This does not tell us much. If we want a single value out of it, we can again drill down and see. Uh, so we can see that most of the values lie in the range of 220 to 40. So yeah, this seems like a pretty standard value. The compression ratio, so more the compression ratio, more is the thermal efficiency of the engine, but this increase in efficiency drops around 10 to 14. So that's why we can see that most of the engines have compression ratio around 8 to 10. Curb weight is basically the weight of the car without any people in it. Drive wheels, if it's a front wheel drive, rear wheel drive, or a four wheel drive, like in case of an SUV. The engine location looks like around 99% of the cars in the US have engines located in the front. Makes sense because till what I've seen is only the sports cars have engines at their back. The engine size is around 100 to 150 cubic inches. Engine type, majority can be seen as of the type OHC, which stands for overhead camshaft engine. This engine is highly efficient as opposed to the OHV or the overhead valve engines, but these are bulky in nature, so uh, that that makes them good for common use because bulk is not a problem. Fuel systems, as we can see, the MPFI is the favorite choice here. MPFI is more durable and has less tailpipe emissions as compared to 2BBL. 2BBL being a bit more efficient. Fuel type, again, not a surprise here. Most of the cars run on gas in the US. This is just the height of the car in inches. Uh, Highway mileage. Highway mileage is on an average higher than the city mileage that we saw before because there are less stops, saving fuel for the user. Horsepower, you can say it's around 60 to 80 is the highest bin here. Then length is 160 to 180. The make, as we already saw, Toyota is the popular choice. Uh, there are normally four numbers of cylinders in a typical car, so that's the highest number here again. Number of doors 2 and 4. Peak rotations per minute, it's the amount of torque a car generates. Again, 5000 to 5500 rotations per minute is the peak RPM achieved by a average car on road. And the price range starts from $5,000 all the way up to $50,000. So yeah, 5,000 to 10,000 being the popular range here. The wheelbase is 90 to 100 inches and a width of 60 to 70.